The creator of Claude Code said 80% of Claude Code was written by AI. Check out this video.
So then the question is, how much of it was coded by Claude Code? Obviously, there's some percentage, but I wonder if you have a number, like 50,
It's
80?
pretty high.
Probably near 80,
Yeah.
I'd say.
Yeah, it's very high.
Now I was a little skeptic until I came across this article that Anthropic put out. It's about best practices for Claude Code. And number 6 in this article really got to me, up-level with multi-Claude Code workflow. This essentially explains how they are setting off multiple instances of Claude Code, working on different tasks in parallel, and all I would have to do is go in after each instance has finished, review the code, fix any bugs or revise changes, and then merge that into the main branch. That workflow in my mind was amazing. So a week ago, I decided I wanted to look more into this workflow and see if it can actually speed up the way I code. And now that I have been using it, I have to say this workflow is actually insane. And I'm going to show you how to set this up. So all you would have to do is type in the command, the number of agents you want to spawn, the branch name, and then the markdown file containing the plan that you want these agents to execute. Yes, planning is absolutely essential in order to make this parallel workflow work. I do use Claude Code to help me generate and modify the plan before giving it to another instance of Claude Code to spawn the agents and work on the plan. I am using Claude commands to execute this whole parallelized coding workflow. As you can see in here, I have a parallelize.md file, which is a Claude command. It is in charge of creating X number of work trees, as well as responsible for spawning sub-agents and assigning each work tree to those sub-agents. This command takes 3 variables. The first will be number of work trees. This also determines the number of agents that spawned, the feature name, which will be the branch name and the work tree name. The plan to execute will be the path to the markdown file containing the plan for each sub-agent to execute. I've also broken up the execution phase into 2 separate phases. The first phase is basically setting up the projects. It's going to create a number of Git work trees. Phase 2 will be spawning sub-agents and assigning 1 work tree to each sub-agent. Each sub-agent will then review the plan, execute the plan, and then it's going to output a results.md file in each of those work tree, and in detail it'll explain what changes it has made. And here I have a more bespoke, more specific to the project I'm working on. I basically ask it to run a build and fix any errors, because what I notice is sometimes these sub-agents makes changes, and when it's finished, there's actually still errors. So there would be like type errors and some syntax errors, and these are really easy to fix. So I'm just having it run the build command, and then if it finds any errors, just fix it. And that's basically all this command does. Don't worry, I will clean this up, and there will be a GitHub link down below in the description. Before I show you how this command works, I just want to show you one more thing, which is the claude.md file. In here, I have specified exactly where and how I want my plans to be named. Let me just show you my whole workflow starting from the beginning here. I have a session card, and I want Claude Code to redesign my session card since it's a little clunky. This is an app I've been working on for just a few days. I got it working. Basically, it's gonna streamline the whole process of parallelizing workflow. Think of it as like OpenAI Codex clone, but for Claude Code, and it runs locally, so it doesn't cost extra than your Claude Code subscription already. So this is what I wanted to reimagine. I'm gonna have it output a detailed modification plan into the specs folder. So let me just queue this up. All right, it has created the plan. So this is what I would do. I would review the plan. I'll go through it, literally read every single detail in this plan, make changes if needed. If it's a small change, I'll make it myself. If it's a large change over the whole plan, I'll have Claude Code do it. So I'll go back and forth, or I'll have it analyze more code and update the plan accordingly. Once I've gone through this, what I'll do is then I actually close this instance of Claude Code. Before I forget, I always commit the plan so that it's saved. And if anything happens, I can go back to the plan and move forward from there. To actually execute this plan, I'm gonna first open Claude again, but this time I'm gonna use a flag. Only do this if you're YOLOing, okay? It's gonna be called dangerously skip permissions. And what this is going to do is going to allow Claude to go ahead and execute commands without you actually having to approve or having to go back and forth with Claude. When you're setting off, for example, 5 agents implement this plan all at the same time, I don't want it to come back and ask me, can I run this write operation? I'm like, no, just do it. I don't want to know anything until you're done. I'm just going to name the work trees session card redesign, and I'm also going to pass it the O2O-session card design v1.md. I'm just going to execute this command. Once it has created these work trees, it's going to copy any environment files that exist in here into these work trees as well, so that when I do go into these work trees when it's done and actually open up and run the project, I can actually run the project. It's now going to launch 5 sub-agents in parallel and implement session card redesign plan. It's probably going to take 10, 20, up to 30 minutes. I've seen it just do its thing for 30 minutes. It's kind of crazy. At this point, while Claude's doing its thing, I would open up another instance of Claude and start planning my next task. Finally, it has completed the 5 parallel tasks that I gave it, roughly 10 minutes each. Let's just take a look at the design for number 1. I think this looks a lot better. Number 2, yeah, this one's borked. Not quite there in the you-know-what. Let's go to design number 3. Literally had no changes. To number 4. I just don't like that this is not aligned. Number 5. This one's like even more messed up. Sure, there's some RNG here and there, but again, by utilizing this parallel workflow, it saves you so much time. Rather than just using one agent and continue iterating over and over, waiting for it to complete tasks. No, this is all of these agents all at the same time. It goes to do its thing. You work on the next plan. You launch that next plan. Now you are a one-person team. You literally can have as many parallel running agents as you possibly want. If I wanted to merge session card redesign 1 back into my main branch, all I would have to do is I would just run git merge session card redesign 1, and that would merge session card redesign 1 into the main branch. However, usually what I like doing is I would go back to the actual session card redesign 1. I'll first commit all this, and I will actually work inside this work tree until I feel like it's good enough to merge back into the main branch. And that leads me to the second command that I want to show you. And this one's really simple. It's a cleanup command. Basically, it cleans up all the Git work trees created by parallelize command. It removes all the Git branches, the Git work trees, and all the folders under the trees directory. So here I'll show you how it works. I just go /cleanup. As you can see, it has completely removed all the Git branches and Git work trees from the directory, as well as completely removing the trees folder inside my project root. I hope you enjoyed this video. I'll see you in the next one. Peace.